okay, first of all, a one-tailed, two-tailed test, the only time it's really that important is with a t-test. So the rest of your tests that you're about to study, they're all done automatically. You don't even have to look at them. But with a t-test, you're supposed to tell whether it's a one-tailed or a two-tailed. So this is how you tell. If you think one of your groups is going to be higher or lower or more than or less than or faster than or slower than, you feel that you're picking a side that's going to win. If you can feel that in your analysis, that makes it a one-tailed test. It's called directionality. But if you're not sure or if it's not stated, that makes it a two-tailed test. A good example would be a researcher wants to find out whether there's a significant difference between the number of head injuries between soccer players and swimmers. And it doesn't tell you who is higher and who is lower. That would be a great example of a two-tailed test. But this one, they pick one, right? They say are swimmers higher than soccer players? That makes it a one-tailed test.
Okay, so one-tailed is if we're leaning towards one group, right? Or one.
Exactly. So in other words, if you could see like a greater than sign or a less than sign in your head about one side being higher than the other side or anything like that, that automatically makes it a one-tailed test.
Okay.
All right, so let's fire this data up. Here is the data. We're going to enter it. So first thing we're going to do is we're going to make a new variable. Hold on, get in there, you. We're in data view. We're going to go to variable view. I'm going to make a new variable, and I'm going to call it sport. And I'm going to spell it right. Dang, sport. And the values, it's going to be a categorical. We'll call ones swimmers and two soccer heads. Okay, so that's a categorical variable, and we're gonna call that a nominal variable. Okay, the next one is, what is it called? Head injuries. What are we measuring? Long-term neurological deficits. That's quite a, okay. So now I don't want to name it that because that'll throw off our, it'll get kicked out if we name it like that as is. So I'm going to go to the variable view. I'm going to put this in the label and it'll show up, right? Long-term neuro, I'm just going to mark this, what do you want to call it? Neuro deficits. That's the short name. And that is going to be a regular number. A regular number, where 17 is higher than 5, that is called a scale number, just a continuous number. So now we're cooking with gas, and now we got to enter the data. So how many do we have? We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 swimmers, right? So we're going to go to the first variable called sport, and we're going to put in 15 ones. The speed of light. Bam! Oh, that was fast. Let's find out how many soccer heads we got. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. We only got 14 soccer heads. So those are 2. So we're going to do 14 twos. So 14 plus 15 is 29. So I need a couple more, right? Is that right? What happened?
So this is like where we are putting them in categories.
Correct.
Like how we did last time, huh?
Correct.
Okay.
Now, this is just me. These variables that have decimals when you don't need the decimals, that's me. It just kind of bugs the shit out of me. So the sport guys, a 1 means they're a swimmer, 2 means they're a soccer guy, right?
Yeah.
So now we're going to enter let's do the swimmers' numbers first. Okay, so the first guy's a 10, 8, 7, 9, 13, 7, 6, 12, 9, 8, 11, 6, 10, 7, 9. All right, let's make sure we got them all. Yay, us, we did. So now we're going to switch to the soccer heads. 7, 4, 9, 3, 7, 9, 10, 6, 7, 9, 10, 5, 7, 9. And we're good to go. Okay, you're going to save it. Make sure you save it. And we're going to put this in. Nope, not going to put it there. We're going to put it. I think it's there. Yes. Fall. This is everything I've done so far this semester. Isn't it crazy? Oh my God, that's just in. Oh my God, SPSS. But you got a special folder. Okay, and this was. This is homework 03. Fresno. Save. Stop it. All right, we don't need that yet, so. First question. What are the HO and the H1?
So I always heard HO is the alternative, right?
No, the HO is the null.
Okay, so O. And the null is the opposite of what you predict is going to happen?
Kinda. That's a real close answer, yes.
Okay.
So but not the null, you write it like this. HO. Then you're going to say the mean of swimmers will equal the mean of the soccer players.
So it's like there is no difference. That's what the null would be.
Always. Good, good. Now we could clean this up a little bit. We can say I'm going to make it fancy. I'm going to do H sub O, and it's a 0. And then I could go in and I could put in, I'm going to put in an equation. And I'm going to do one of the scripts, I think. No. One of the accents. One of these has a place where you can do means. There it is. Bam. So this is going to be X. And then we'll do a little subscript. Oh, can't do subscripts here. Let me see what I can figure. So the X of the. Now I can do subscripts. We'll do subscript, boom. Equals the. Equals the mean of the soccer. I'm just going to call them soccers. I'm easy. So there's the HO, and the H1, it looks almost identical to this. H1 just means it's an alternative hypothesis. Some teachers make you guys write HA. So we're going to say is greater than And all we do is we change out that equal sign to a greater sign, greater than sign.
So, like, if we put it into a sentence, like, because is that like APA format? The mean of the swimmers equals the mean of the soccer players.
When you write it out, yeah, when you write it out for your dissertation, you're going to write it out something like this, right? This thing is for old stats teachers like me. But this is how I read this, right? I can make that more fancy as I go. So this one, oh, I screwed that up. Hold on. That should not be there. So, right, the null hypothesis states that the mean of the swimmers will be equal to the mean of the soccers. And
So can we say that there is no difference between the neurological deficits between swimmers and soccer players?
Perfect, right? Right, so I'm going to put that in there, right there. In the number of right between the swimmers and the soccers, right?
Okay, and then the alternative. I'll wait for you to finish.
I don't know. We got it. We're here.
So then the alternative. So the mean of the swimmer is greater than the mean of the soccer players. So we could say that neurological deficits in swimmers, or there are more neurological deficits in swimmers than in soccer players.
Yeah. Swimmers will have a significantly higher number of severe lung than the soccers, right? Right? Or so far so good, right? So now we're going to try to shoot down the old null. We're going to shoot that sucker down because if we shoot down the null, we can accept the alternative as true, okay? So degrees of freedom for the test.
Does that mean we have to run it?
No, not at all. Degrees of freedom is the total number of people minus the number of groups.
Like always?
Always.
Total number of people minus number of groups.
Right. Total number of, I think we call them subjects, minus the number of groups. And we're going to back this up when we run it through SPSS. So your degrees of freedom are going to equal 29 minus 2 equals 27. 27.
Why do we, what's the purpose of the degrees of freedom?
Degrees of freedom at this point in the game is basically it's telling you where to look on a p-value table. On a p-value table. So, but we don't use the table anymore. So degrees of freedom, it's what we call wiggle room. The less degrees of freedom you have, the more wiggle room we have when it comes to finding p-values. But it's kind of a dead dead horse. We don't really use it anymore. It's a good way to tell you how many people you have in your study,
Yeah.
right? So it's basically it's telling you how many people are in your study minus the number of groups. And I don't lose any sleep over the real meaning of it because it's complicated.
Oh, okay.
All right, you ready for the box plot?
Yes. So that means that we have to run it now.
Yes. We're going to go to. Ba-na-na-na-na-na-na-na. We have more than one way to do this. I would probably start by doing this. I'd probably go to Analyze, Descriptives. I would go to Explore. And our dependent list is our DV. That's our neuro. And this will split them up into the swimmers, one for the swimmer and one for the soccer heads. And start clicking over here. This is the default. You're going to get a bunch of data about each of the variables, even though you didn't ask for it. Plots. We do want plots. It's going to go ahead and give us a box plot, right? Right there, box plot. I'm going to undo this. I'm just going to keep the box plot. And let's see if I have the option of, will it do them different? Yes, it's going to do them different. And I think that's basically it. Now, we don't have to get the plots. We don't have to get the statistics. You can unclick them. But I'm just going to, we're just use the default. Usually is the right way to go. So we're going to click on both. Click OK. And you're going to get two box plots with all the trimmings. There they are right there. So we're going to right-click, copy. And we're going to put them right here. Damn, that's a big graph. Ooh. Yeah, let me make it a little bit smaller so it fits on the page up there. Get up there, you. Boom. Okay. Now I'm going to show you the other way to do it, just to see who's paying attention out there. We can go back to our SPSS. We could go to Graphs, Legacy, Box Plot, Simple. And the same thing, right? The variable is the DV. And if you want to split them up, you got to put these into one of these. That's the right one, category. Don't care about options. And you should basically, yeah, you get the exact same thing. So it doesn't matter which way you go. There's your two box plots.
I don't know what happened.
No worries, no worries. I realized it started blinking at me and went, somebody kidnapped Summer. No.
Okay. Maybe I have to click. Oh no.
Can you still see me?
Still there. Oh yeah. Yeah, okay.
All right, so it asks which t-test the equal variances are not equal, and it's the equal variances assumed. So that would be this row.
Why?
Because the variances between the groups was not violated. So in other words, the equal variances was assumed and it was actually supported too. So now if this Levine's number was the
It was uh
uh-oh. Hello. Yeah, you're cutting in and out.
oh, I don't know what's happening.
It's the internet. It always is the internet. The stupid internet in my house goes down all the frickin' time. No, so if this sig value for the Levine's test was less than 0.05, then you would use this row of data. But now I want you to make a quick look. Look how close the numbers are to each other. They're only off by what, 1,000th? So really, they make such a big deal about it, which I wish they wouldn't, because it's not that big of a deal. I'm starting to find out in real life. So, but again, because it did not violate the assumption, we're going to use the equal variances assumed row. General statement. I'm going to go back up here. I'm going to cut and paste this bad boy. And we're just going to add in some stuff. Hey. Get out of here, you. Okay, so it's gonna be like this. According to the SPSS output.
For G?
Yeah, let me rephrase that. We're gonna oh my goodness, hold on a second. We're gonna say what does she call it? A two-way?
Two sample t-test.
Okay, a two sample t-test indicated that there was a significant increase in the number of neurological deficits in swimmers compared to soccer heads. Indicated, where'd it go? Oh. A two-sample t-test indicated that there was a significant increase in the number of in swimmers compared to soccer heads. Now, so swimmers, this is where you put your mean and your standard deviation, and we get those from up top.
Swimmers.
Right, the mean was 8.80. You only go out to two place values. Where'd it go? So 8.80 standard deviation for swimmers. Where'd it go? 2.11. And we're going to go ahead and do the same thing. Oh, let's get it all cleaned up first. Man, oh man. And then we're going to find out what the soccer heads were.
Do we have to put the N?
No, it will show up in what I'm about to do here in a second. So 7.29, where'd it go? There it is. So the soccer heads, 7.29. And I believe the standard deviation was 2.20, but let's double check. Yeah, 7, right, okay. Now this is where we write up the rest of this stuff. So we tell them what the means were and standard deviations were. We put a comma, and then we use the t-test, parentheses. This is your degrees of freedom, 27. And then we put equals, and then when that's the equal, that's your t-test statistics, so 1.892. 1.892, comma, you put the p-value in there, p equals 0.0345, comma. Now, I always do effect size. I don't know if she wants effect size or...
Wait, where'd you get the 0.0345 from?
Divided that by 2.
Oh, okay. Oh my gosh. I need to remember that. I'm gonna forget that. Okay.
Yeah, it's an evil trick question.
Okay.
But, it is, for the t-test, you are going to run into a lot of cases where you think therapy has improved somebody's condition, so that makes it a one-tailed t-test. So, okay, and then I don't see anything about effect size, so let's just leave that blank. But this is APA formatting. So a two-sample t-test indicated that there was, we got to mention the assumptions. I would say the data did not violate any of the assumptions. We're going to have to check it real quick for normality. And in parentheses, to show her that you know what you're talking about, it's going to be normality, independence of observation, and homogeneity of variance.
Okay. So because it was not significant, then we say that the equal variances are assumed.
Correct. We say the assumption did not violate, or the data did not violate the assumption,
Okay.
which is the same thing as the equality of the variances was assumed.
Okay.
But now,
Then we use that the top data. But
yeah,
if it was significant, then we would say the equal variances was not assumed, and we use the bottom data in the box.
if it was assumed, you would use this bottom data, the bottom row. But it wasn't. The data was not, it did not violate what we're looking at here. So you would use the top box.
Okay.
Now, we have to check for normality because we mentioned that it didn't violate anything, so we're going to double check, yeah? There's no way to check for independence. We just assume that's right. All right, so let's go back to our data set. And we can go to, get back in here, we can go to Analyze, Descriptives. I always use Explore, and again, there's other ways, but I'm just an explorer at heart. And I'm going to go by just one neurodeficit. I just want this, the normality plots. That's going to give us the math tests that check for normality. We don't need...
You don't want the sport in there.
Because the sport would split them into two. It would give me the normality for just the swimmer guys, and then a separate normality for the soccer guys. And you don't want to do that. Your sample size is too small. It's probably going to violate the assumption anyway. The smaller the sample size, the more chances of you violating the assumption. So you want to keep your sample size as large as possible, especially when checking for normality. So again, okay, put that in there, plots. We really don't, let's do a histogram, but histograms can be misleading. Click OK, and then swinga. This one, this is right here.
Yeah.
Your Kolmogorov-Smirnov test. This will tell you if the data violates the assumption of normality. So it's 0.133. That's the sig value. So did this data violate normality, yes or no?
No.
Correct, it did not. And that almost looks normal.
Yeah.
So remember, the data doesn't have to be perfectly normal, but it has to be kind of normal, and this data is kind of normal. So let's just put those in there just in case anybody wants to see it. Bam. Okay, that's it for one. I think that's everything answered pretty well. You want me to walk you through two real quick?
A two sample T-test. That's the same thing that we just did, right?
Yeah, but she wants you to make up your own.
Okay. No, I think I should be good on that because I could just follow like the example of this question.
Good. Remember, you need two groups.
Yeah.
Now, your IV is going to be a group of some kind. So let's say you want to compare somebody that got CBT therapy and then somebody else that got ACT therapy, and you're measuring their depression scores or something like that. So the DV would be depression scores, and your IV would be therapy with two levels of the groups, ACT and CBT, and that kind of thing, right? So,
Yeah.
You're right. And your HO would be there's no difference between the scores, depression scores based on therapy. And if you wanted one to be better, like you expected CBT to be better, you would say the depression scores for CBT patients would be significantly lower than the ACT patients. So
And then the paired example t-test would be like that's the one that has like three, like where it could be like a pre and post test, or that's the only one I remember from the.
that's it. That's the main one. That's 99% of the time a pre and paired post test. That means everybody's in the same group,
Mm-hmm.
but they got measured twice.
Okay. Okay. Yeah. I don't know why that one's easier to understand.
It is. It's the IV. You have a variable for the two-way that's not really an IV. It's just a grouping. It puts your subjects into group A or group B. That's difficult to wrap your head around. I know I had the same problem when I was trying to figure this stuff out. But it just allows you to work at an SPSS. That's why we call it an IV, a categorical IV with two little subcategories. That's what it's all about, I guess.
Yeah. Okay.
All right, I think you did fine. I'm going to give you an A plus.
I hope I get an A in this class. Gosh.
You will, I guarantee it. So what I'm going to do is I'm going to make the quickie video and I'll send it to you, and I'll send you the answer sheet we got here, and you can send it to anybody you want. How's that?
Okay. Yay. Thank you.
Summer, it's always a pleasure.
I'm gonna go because I think we have our midterm next week, so I'm gonna go over I'm gonna go through the study guide and do everything that I know, and then probably next Monday, um, go over the study guide with you.
That is fine. I am here for you. So, all right, I appreciate your love of statistics.
I appreciate your love for statistics.
I'm a nerd. I can't help myself. So,
Okay.
all right, I'll talk. You have a good week. You have a good week. I'll talk to you next Monday.
Bye.
Ciao.